Hi there, Algebra 1, 6.1, Solving Systems by Graphing. Objectives: to solve systems of equation by graphing, to analyze special systems. Alright, solving a system of equations by graphing. You have y equals x plus 2, you have y equals x or 3x minus 2. We have to graph these. We are going to go over to the graph board. Okay. So, we'll stay basically right here. Okay, and we go across. And we have this. Alright, so we have to find out how to graph this. We have y equals x plus 2, and we have y equals 3x minus 2. Okay, at this point, we're going to start with this one. Alright, my y-intercept, which is this value we've learned in the past, is where my first dot is going to be. So it's going to be at positive 2. 0, positive 2, because that's where the y-intercept is. And we're going to go 1-to-1 ratio, which means on a grid paper, we're going to go up 1 over 1, up 1 over 1 to the right. Obviously, it's a positive 1, so we are going up and to the right. If it was negative, we'd be going down and to the right, or up and to the left. Which right now, I am going down and to the left, because two negatives make a positive. Alright, so that got me that one. Alright, now on the other one, we have positive 3. So we're at 0, wrong number. This number is our y-intercept, which is at negative 2. Okay, so we are going to go, we're at negative 2. Our slope is positive 3. 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. So our lines will cross at this point, which tells us that these lines, the solution for both of these lines is this point right here. So that is 1, 2. Alright, up. 1, 2, 3, 4. You have 2, 4. That is your answer for that one. Okay, the next problem we're going to do, instead of moving you over, I'll just write it up here. Is going to be y equals 2x plus 4 and y equals x plus 2. Alright, so at this point, basically you get 2x plus 4. Well, the 4 tells us that we are on our y-intercept, we're going to be at 4. 1, 2, 3, 4. Okay? We are going to have a slope of 2 to the right 1, because it's positive. So we're up 2, 1, 2, over 1. Up 2, over 1. Down 2, so we go to the left 1. Down 2, to the left 1. Down 2, to the left 1. And then we play connect the dots. Okay, there's my point there. Now we have at our other one's going to tell us our y-intercept's at 2, so it's right here. Alright, so we're at 2. We need to rise 1 over 1. So we're going to rise 1 over 1, rise 1 over 1, rise 1 over 1. One thing is I'm graphing, I'm seeing I'm getting farther away, so I'm going to go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. And we should have a line that goes through right here. Okay, at this point, this is going to be the point in which makes both of these true. We get negative 2 0. There is our solution for that one. Okay? We got to find the point in which they meet. That is the whole point of graphing system. Alright, so if you go to your book, as long as you're not in class, I have it obviously on my PowerPoint, but we have scientists studied the weight of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? Okay, so alligator 1, if you're looking in your book, tells you that it initially weighed 4 pounds and has a growth of 1.5 pounds per month. Alligator 2, initial weight was 6 pounds and grows 1 pound every month. Okay, so if I create a chart, or a coordinate plane I should say, okay, it's going to look something like this. Now, we're working with weight and time. Am I ever going to be probably looking at a negative time in this? Well, not when I'm talking about your growth, probably. Unless you're looking back at it, but if I'm graphing it, that probably should start at month 0, 1, 2, and so on. Your weight, obviously, yes, it can go negative, but it can't go below 0. Otherwise, you are non-existent. I mean, if you're talking about like weight loss, you could go negative, but not your body weight itself cannot disappear. So these alligators cannot be in these quadrants. This is the only one that's positive, and with time and their body weights, I'm hoping it at least stays above 0 on both of them. So, let's go months over here. We're going to go, actually, I like time on the bottom. Let's go weight over here. Alright, and time. Okay, so once again, alligator 1. He is going to, his total weight is y equals, alright, so initially they weighed 5 pounds. So automatically I have to add 5 pounds to it, whether it's times 0 or whatever. So my time, we don't know right now. So that we're going to make an x. Okay? The amount of time is going to be taken by, and this one weighed 4 pounds, my bad. So you got 4 pounds times 1.5. Alright? So this one, your y-intercept is going to be 4, and your rate is going to be 1/2. Okay, so 1, 2, 3, 4. Okay, I don't like 1/2. I really don't. So I'm going to basically multiply the top and the bottom by 2. So I'm going to multiply the top by 2 and the bottom by 2 to get a number in which I know will be a whole number. So I end up with 3 over 2. Okay, at least now my top is a whole number. I feel a lot better about that. So I got to go up 3 over 2. Up 3 over 2. Up 3 over 2. And you have something that looks like this. Okay? And this would be 1 month. No, that'd be 0. 1, 2, 3, 4, 5, 6, 7. Now, obviously, I didn't stop at 1 month because I already multiplied by 2, so I'm going to go up by 2s, obviously, like, I'm taking 2 steps. I'm going up by 2 months because of the fact it's easier on us. Okay? And this one would be pounds, would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, this other alligator, if you recall, he weighed 6 pounds to start out. So my 6 is going to go there. Alright, we're going to add that to whatever his weight is. Whether he's at times 0 or if he's at till the point of his death, pretty much. Alright, he's going to have to be at least 6 pounds. Okay? He is going to gain 1 pound a day. So he's going to be going up by 1 over that amount of time. So that is going to be my x. So my y-intercept is going to be 6. So I put a dot there. That's starting out value at time 0. He weighs 6 pounds. All right, and we are going to go up by 1 over 1. Because every month he's going to gain a pound. Over another month, up another pound. Over another month, up another pound. Over another month, up another pound. Over another month, up a pound. Over another month, up a pound. And you have something that looks like that. So right here, and if you look at it, at month 4, 4 months they will weigh the same. At 13 pounds. No, 10 pounds, my bad. At 10 pounds. Sometimes you need to read your graph. I, for some reason, had 13 stuck in my head. Okay, so that would be that one. The other one satellite radio service charges. This is the one below in your book. It is the kind of more your guys' problem to do. It's not the one the book shows you. All right. So I'll create my graph once again. Probably not going to need my other coordinates. All right, one satellite radio service charges $10 per month plus an activation fee of $20. The activation fee is not every month. You just get to charge that initially. And that is something you will learn in real life. A satellite service charges $11 a month plus an activation fee of $15. In what month was the cost of the service the same? So we got to create equations for this. The first one, your total is going to be y, and that's going to be equal your $10 per month, and we don't know how many months, so we're going to put an x in there for the months, plus you got to pay this initial fee. And this is your total bill after so long. You're trying to see what's the best option for you. Okay? Okay, so now we have that. So now we're going to take that and we got y. The other equation is y. Okay, they're going to charge you $11 times the number of months, which we don't know, plus I think they charged an activation fee of $15. So there's my two equations. Obviously, didn't leave myself enough space really to graph this now. So once again, I'm going to put months down here. The reason I like months on the bottom is it's pretty consistent. Time is usually something you can mess around with a little bit, and it's going to usually pretty well stay always the same. Now, like your money or your service charge, what do they call it? Your fee. Let's go fee. Okay, that is going to go up a little bit different, and I'm going to go up by 5s. 5, 10, 15, 20, 25, 30, 35, 40. Okay, so first equation here, it's going to be at 20 to start out. Then each month it's going to go up by 10. So 5, 10, okay, and that was 1 month. So over 1. Up 10 again, and another month. So that's month 2. So maybe we should keep going up a little bit more. That's not very long. I'm trying to figure it out. And man, if it's that simple, I think it's a no-brainer which one to go with. So probably won't be that easy. All right, so we got to go up another 10 over 1. Go up another 10. Over 1. Go up another 10 over 1. I went over 2. Alright, so there's my line here. We'll see if it works. Maybe we still gotta extend it. Okay? This one, we're gonna start at 15, and we're gonna go up 11, and we're gonna go over 1. We're gonna go up 11 again, and over 1. We're going to go up 11 again, and over 1. We're going to go up 11 again, and over 1. We're going to go up 11 again, and over 1, and we should hit right here. So while my graph, since I only went up by 5, is very close, it is not actually until up here at month 5 that it is the same at $70. So your answer is the 5th month, or after 5 months, whatever. However you want to answer it. But it's during that 5th month, it'll be the same. All right, so now going back away from the word problems a little bit and just kind of a certain situation. Okay, if I give you an equation, I give you two equations, and the one is 2y equals, it must be minus x equals 2, and y equals 1/2 x plus 1. I have to graph these. Now, here, I'm going to add x to both sides, because I'm not even in standard form. 2y equals x plus 2, divide by 2, divide by 2, divide by 2. You get y equals 1/2 x plus 1. Okay, both of our equations look the exact same. That's odd. We get 1. Okay, you're going to have to go up 1 over 2. Up 1 over 2. Up 1 over 2. And it looks like this. Okay, now if you go do the other one, you're going to come right back here. And then you're going to go up 1 over 2. And you're going to keep hitting the same spot. This means that both of your lines are on top of each other. Which means how many points are they at the same, or do they cross? Well, all of them. So it's all real numbers, or infinitely many solutions. Let's go infinitely. Infinitely many solutions. It's all the solutions on those lines. I guess it wouldn't be all real numbers technically. That is incorrect by me stating that statement. It is infinitely many solutions. There's more than one, and there's so many we cannot decide completely. All right, what about, I give you two new deals. And honestly, this next one should be drawing a red flag. Actually, both of these last two should have. Okay, so our equations are y equals 2x plus 2 and y equals 2x minus 1. Okay, so our first one we're going to be up 2. Our slope is 2 over 1. 2 over 1. 2 over 1. So we look like this and that. Okay, the other thing is this one's going to be at -1. You're going to be up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. So your other line's going to look like this. Therefore, these lines will never cross, which means there is no solution. Because these two lines will never cross. If you recall, the equations themselves here from your last chapter told you anytime your slopes are the same, the lines will be parallel. if the lines are parallel, we're making a connection to that, then they're never going to cross, which means neither one of these will ever get it where we can put in a point into both of these and get both equations to work. Okay? Okay, this slide is just showing you more examples. Okay, if your lines cross and they intersect at one point, then they have that direct deal. They are going to be independent. They are consistent and independent. Because there's only one option. Alright, if your lines are the exact same, you're going to have infinitely many solutions. The lines are the same, the lines have the same slope and y-intercept. The equations are consistent and dependent, meaning they are very much dependent on each other. The lines with no solution, when they're parallel, lines are parallel, the lines have the same slope and different y-intercept. The equations are inconsistent. There's your homework.